a data set, time and number of bacteria cells. We can see it's increasing. Once we've got our data here, a quick look graph. Doc, insert a data and statistics. Always nice. These are all my variables from my previous insertions. So I have to go back to 1.1 and see what it is that I've got in here. This is T and N. Okay, so I need T and I need N. Okay, so you might think, well, exponential kind of makes sense, but then it's kind of curving off here. And those of you who've played with logistic model, which we're going to do next, you might think, well, maybe logistic model. We're going to stick to exponential, because that kind of makes sense for biology cell reproduction. And on this screen, we can have a look at the different models: menu, analyze, regression, and let's go for exponential. That's what it looks like. Now, of course, it fits beautifully down here, but you can see that for the later values, certainly 20, look how far off. The model predicts this amount, but the actual amount is here. And over here, of course, the further on this gets, maybe the less accurate the predictions are. So while the model overall is a good fit, for certain values later on, for bigger values of t, it might not be a good model, right? Might not be a good fit. But that's quite weird, because when you go on here, menu, statistics, stat calc, do your exponential regression here, and this was again t, and this was n. Look, save equation regression to F1. That's important. Okay. Now, when you scroll down here, you get the idea that A is 42.9672 times by B, 1.7351. Those are the same figures that we had here in our model. Look, 42.967, 1.2735. But down here, of course, we've got the R squared value, the coefficient of determination. It's pretty high, right? Overall, the model is a good fit to the data set there. Now, let's just do something else, because this page is nice, but do you remember our magic Control T? Control T table of values doesn't work on this page, right? So if we go Doc, insert a graph now, and we go up, there's our equation for our exponential already saved as F1. So press enter. You can see it's over here. We need a suitable scale, Control T. Control T shows you the kind of values we need to have a suitable scale, right? So I'm going to do Control T again, toggle that off. Menu, window zoom, window settings. The X, I'll just go from -1 up to 30 maybe. And on the Y, I will go up to maybe 5,000. This is what I've currently got. Quite nice, right? But wouldn't it be nice to see our data plot on here as well? Yes, it would. Thanks for asking. Menu, graph entry. Can you see it? Scatter plot. So now we're actually going to bring in our scatter plot onto our graphing. Let me just put the N in the right place. Beautiful. Now you've got a kind of a decent idea about what the data points look like, okay? And so you can see here they don't look too far away, but look at the scale, all right? And then finally, we needed to make a prediction, didn't we? I think, there we go. Use your models to predict bacteria cells at 22. So the input's 22. Now watch the magic. Doc, insert a calculator. What was our equation called? Was it F1? Type in F1, open bracket 22, boom. Okay, you've got an input-output automatic generator, all right? You don't have to go to the table of values. You don't have to calculate on your calculator. It's there built in. Top tip, right? And the final question was, use your model to predict the number of cells at 35, so F1 bracket 35. The benefit of this, of course, is you can do, a decimal prediction, right? 20.43. You're not going to have 20.43 number of hours on your table of values, yeah? So obviously table of values from here, Control t. The default is that your x variable goes up by 1. You can adjust this, you can adjust it, and you can type in numbers for x to get outputs, but I kind of like the idea that you've got it all stored there for you. Now, finally, comment on how good these predictions are. Well, look, F1 of 22 is 8,700. But look, it doesn't make sense, does it? Because 20 hours, there's already more than your prediction. So it's not a great prediction. And that's how you have to comment. Sure, we're doing interpolation, so it should be a good prediction, but you can see that actually the data points towards the higher t values aren't very accurate. So that's what we need to do. The final question, make a comment on t equals 35. Of course, t equals 35 as a prediction is not good because we are extrapolating. We only know how well the model fits the data for the current domain, and the domain is 0 to 28 hours. Good? So top tips. When I am doing this, I'm thinking, first of all, a spreadsheet. Has to be a spreadsheet. Then I want a quick look at the data. I think the best quick look is on the data and statistics because it automatically chooses the correct scale for you. Then I'm going to fit a model on this page. Once I've chosen a good model that I think is good, I'm going to go back to my spreadsheet and I'm going to put the model on here. And the reason why is it gives me the R-squared value, obviously, but it also saves it to F1. Once I've done that, I'm going to insert a proper graph on a graph page. I'm going to plot F1, plot the scatter graph, and I've got my table of values. Finally, I'm going to insert a calculator page, and I've got an automatic F1 of 1.5. Yeah. The only extra thing we could do here is work out the percentage errors that our model gives us. Yeah. And I think a final thing, I'm not sure if it is on, I think it's on here. If I go menu, plot properties, plot type, I think I'm trying to plot the residuals, but I'm not too sure where that is. Oh, there you go. Residuals, show residual plot. And this residual plot shows us exactly why our predictions are not great. Look, this along here, this tells us basically how far our real values are away from our model predictions. So you can see over here, that's quite a long way away from being a good prediction, and certainly this one's a long way away from being a good prediction, yeah? So the residuals is a good way of saying, actually, for early t between 0 and 16, good model. For late t between 16 and 28, bad model. Residuals, all right? Do you remember where that was again? Menu, was it analyze? And it was residual 7, okay? And I'll hide residual plot. Brilliant.